we have learned what a space curve is if it's a curve in R3, what a plane curve is if it's a curve in R2. And that is equivalent to a vector valued function in R3 with 3 components. R of t equals x of t, y of t, z of t, over parametric equations. X equals x of t, y equals y of t, z equals z of t. Okay, this is in R3. All right, so now we have a task. We're given a space curve in the form of vector valued function in R3. We want to find its tangent vectors, so that's r prime of t. Second, we want to find the length of r prime of t. So when I see this notation, I know I'm looking for the length of the vector. Doesn't matter it's just a vector or it's a vector valued function. We know we're looking for length. Last, we want to find the dot product between r of t and r prime of t. So this is a notation we've been using. Sometimes we will see people use angle parentheses. This is another way to express dot product of 2 vectors. Okay? All right, let's go ahead. R prime of t is the vector given by derivative of the x component, derivative of the y component, and derivative of the z component. Okay, so you should think this notation ddt as a verb, like it's an action. You're gonna differentiate this function. Differentiate this function. Okay, so let's go ahead and find this derivative. In here, I see a constant times a composite function. If I have a constant, I keep the constant there. If I have a composite function, I differentiate the output function, the outside function. So the derivative sine is cosine, and the derivative of the inner function, that's 4t. Derivative 4t is equal to 4. So in here, I use the chain rule. I use the, when I differentiate a constant times a function, this is the same as the constant times the derivative of the function. And I use the derivative of sine equals cosine. Okay? Then I use a power rule where n equals 1. So when n equals 1, you have ddx of x, that is x to the power 1, equals 1 times x to the power 0. X to the power 0 is equal to 1, so 1 times 1 is equal to 1. That's how I get 4 times 1. Okay, ddt of t is equal to 1. All right, move on to the next. I have 2 functions multiplied together. One's t and one's e to the power t. So the root falls onto t. I have 1 times the second function plus the first function times the derivative of the second function. So what I'm talking about, I apply the product rule when I have a product of 2 functions. And I applied again the power rule, ddx x to the power n is equal to n times x to the power n minus 1. This rule is true for any n except the case when n equals minus 1. Okay? Oh no, actually, we're fine. I'm talking about n-tidal, so erase this. This power rule is it's true in general. Don't worry about it. Okay. And then I have ddx of e to the x that is equal to e to the x itself. So that's how I get my y prime of t. And last, I have a constant. For any constant, the derivative of constant is equal to 0. And I know that square root x is equal to x to the power half. I know how to go back between square root and the power functions. And then so I have ddx times x to the power half. Now this is n equal to a half. So follow this rule, a half times x to the power a half minus 1. So that is negative a half. So we have 0 plus 1/2 x to the, oops, not x, we're working with t. Okay, power minus a half. All right. Okay, so let's simplify this a little bit. Erase this so then I have one more line. I have 8 cosine of 8, oops, 4t, and that was x prime e to the t plus t times e to the t is y prime 1/2 t to the minus a half. That's my y prime. Okay, so this vector here is my r prime of t, and its geometric meaning is a tangent vector, a vector tangent at the curve at r of t. Okay. Now pause the video if you need to. I'm going to erase this part so that I can continue solving the 2 and 3. Okay. 2. We found the vector r prime t, and we're looking for the length of this vector. What is the formula for the length of a vector? Square root of x component squared plus y component squared plus z component squared. That's straightforward as that, right? Okay, so I can leave it like this, leave it as this, or try to break the squares. So the first 8 times 8, 64, cosine square of 4t. Plus a plus b squared equals a squared plus b squared plus 2ab. So 2ab, then plus a half squared, that's 1/4. T to the power minus half squared is t to the power minus 1. Okay, so e to the t times e to the t altogether is e to the 2t. So now I have 64 cosine squared 4d plus e to the 2t plus t squared e to the 2t plus 2t times e to the 2t plus 1/4. Another expression for t to the minus 1 is 1/t. Okay, so altogether I can say this is 1/4t. Okay, so this is personal choice. You can still leave it as is 1/4 times t to the minus 1, or write it as a fraction. This is your personal choice. Okay, so either this, or you want to simplify it all the way. That's fine. It's up to you. Okay, You don't have to simplify unless the problem specifically tells you to simplify your final result as much as possible. Then we simplify it as much as possible. But in here, it's not necessary. I'm doing it for fun, kind of. Okay. So let me erase this. I should have told you to pause the video. Too late. You can rewind back if you need more time to write. 3. I want to do r of t dot r prime of t. What's the rule for dot product? You multiply two vectors component by component and sum them up, right? So the first one, I have 2 sine of 4t times 8 cosine of 4t. The second one, I have t times e to the t times, this is my second component, e to the t plus t times e to the t. I'm not done yet, plus 1 plus root t times a half times t to the minus half, okay? So remember, t to the minus a half is equal to 1 over t to the power half. When I see a minus sign, the exponent, it means 1 over. And when I have a fraction, 1 over 2 in the exponent, it means the square root. Okay? So this guy here is the same as 1 over root t. It's going to be useful when we simplify the answer. 2 times 8, 16. Sine of 4t, cosine of 4t. Okay. Over here, you can distribute it, or just fact out e to the t. But let's distribute it. So t times e to the t times e to the t, so I get e to the 2t. And the second term, I have t squared times e to the 2t. All right. And then over here, I'm gonna distribute this and then this. So that's plus 1/2 1 over root t. Okay, so this is t to the minus a half. Then I multiply this part. So what do I get? I get 1/2 and then root t times 1 over root t, they cancel out. So this is 1/2. All right. So our final result for number 3 is this guy. Okay. So what does this mean? Suppose r of t looks like this. I have no idea what r of t looks like, but suppose this is the r of t. Okay? Then I have, for this point, I have a tangent vector r prime of t. Tangent at the point where the tip of the vector r of t. Okay, so I have a tangent vector at the point given by r of t. And when I do dot product, when I do dot product, what do I do? Let me push this vector a little bit more forward. Okay. This is the identical copy for r of t. So now I have an angle theta in between r prime of t and r of t. So this dot product gives me the length of r of t times the length of r prime of t times cosine theta. Okay, that's what this complicated value gives you. Length of the vector length of the tangent vector times the cosine of the angle between these two vectors.